Hello and welcome back to another video. Over the past few videos, we've covered a lot of topics, all the way from the core mechanics of Unity to graphics. But as we approach the end of this series, we'll be focusing on something a little bit different. We'll be focusing on the sound system and the particle effect system in Unity. Now, while they aren't really a very crucial part of coding a game, unlike graphics, without which a game wouldn't really feel like a game, and without code, without which it wouldn't run at all, both the particle systems and the sound systems add only a little bit to the game. But the truth of the matter is, that little bit is quite important, after all. It might not be a part of the core gameplay loop of any game, or well, I should say most games, but it is still incredibly important in making sure that the game feels fun to play. With that in mind though, this entire video will be about the sound system in Unity. So let's start. The major things you need to know about the sound system, well, we can start with the basics. The sound system in Unity is really made out of two basic components, the audio listener and the audio source. The audio listener is just the component from which all of the audio is received. So it tells the software where the listener is situated. This is important, especially if, well, you want 3D sounds. You need to know where the listener is. Similarly, the audio source component allows you to play audio clips and also control a lot of their effects. To understand a little bit more about the audio source and the audio listener, we can go ahead and look at some examples. For instance, we can see that I have a scene opened. The scene is actually a very simple FPS game, but it'll work for our purpose. We just want to see an example of how the audio system works. So first, we can look for the audio listener component. Generally, the audio listener component will be on the main camera. It's quite common to put the audio listener on a main camera, simply because the main camera is usually where the point of view is, and in most games, that's also where you expect the player to be. Now, there are a few interesting ways to subvert it. For example, you could have listening devices, or, well, even an entire game based on just making sure that those points of views don't always align with each other, which is an idea, but for now, just the simple part is generally keep the audio listener close to the camera. That way, the point of view remains the same for both the visual and the audio. On the other hand, the audio source components can be placed on any objects which you expect to make or which you expect will produce an audio clip or will play an audio clip. For instance, the projectile over here, we can add an audio source to it by simply going over here, adding a new component and typing in audio source, and it adds an audio source for us. Now let's look up all of the settings and the various things we can do with an audio source. To start off with, there's the audio clip. This is the area where you can add in an audio clip, right? This is the audio that will be played when this audio source is used. The output is used for audio mixing or, well, just adding extra effects to the audio clip, but that's a little bit more complicated and we'll go through that on a later date. For now, the very basics. Mute is kind of, well, self-explanatory. It mutes the sound. All of these bypass ones are ways to bypass different kinds of effects that can be applied by the audio system. And, well, again, while kind of important later for the basics, you just have to know that they exist and don't really do much. The play on awake means that as soon as this object is instantiated, this audio clip inside the audio source will be played. Loop just tells you if the audio source should be played or the audio clip should be played on loop. The priority is interesting. If due to hardware limitations, only a set number of audio clips can be played at a time, well, this makes sure that those audio sources with a lower priority, well, a lower number for priority, for instance 0, that's the highest priority, they get played first, and the other sounds might not get played depending on the hardware limitations. Volume, again, quite self-explanatory. The pitch is just how high or low the voice is, the sound is. The stereo pan lets you choose which side of the headphone the voice comes from if you're doing that. And the spatial blend is an interesting component. If the spatial blend is set to 3D, the sounds, whichever the audio source is making, are going to be treated as 3D sounds and are going to attenuate with distance, while the 2D version would just make not the same noise no matter how far or close away the source might be. And finally, you have the reverb zone mix, another kind of complicated topic that we don't really need to go into at the moment. With all of these things covered though, we can see how we want to generate an audio, for instance. Maybe I want to add an audio that as soon as I throw this projectile in this game, this projectile is supposed to be a grenade, for instance. Then it should play maybe a throwing sound. Now over here, we can just select this button to select whichever audio clip we want to. Here I've got a lot of audio clips directly from the asset store. These are free assets, but this can be almost any kind of audio clip, even one that you record yourself. You can click here to listen to the audio, and for instance say I want Canon 1 to be used for it, so I can just select Canon 1, and well, there we go. And I just make sure that play on awake is checked. Now if I run the game and ignore everything else, this is supposed to be a very basic FPS with a health bar and an enemy meter, but the important part is just the audio. I can press and hold G to throw the grenade, and when I release it, you can hear the audio of the grenade throw, right? And well, that was an incredibly simple way of adding an audio. And well, it works wonderfully. But let's say I also want to have an audio play when it hits and explodes. Well, one way to do it would be to just say that we add another audio source. This time we add a clip that we want for the explosion. For instance, maybe I want something like maybe something like this. That's too long. Well, sure, why not? Something like this perhaps. And I don't want it to play on awake after all. Well, we just decided that this should happen when the grenade explodes. That's gonna be the end when it hits the target. So we can check play on awake. We can make sure that it's unchecked at least. But then how do we actually make it play? Well, that's where scripts come in. We can also handle audio through scripts. So if we go into the projectile script, well, most of this is not necessary. The only thing we need to know is when it collides, over here, it will eventually destroy itself. Before it destroys itself though, we want to make sure that it plays the audio clip. So perhaps over here, we can say that when the on collision enter, I want to play an audio clip. So the first thing we do is make sure that it has a reference to, well, the audio source component. For that, we can first use the namespace for Unity engine.audio. Then we can have a public field for the audio source. Now that we have our public audio source, right, which we can connect later, we can go down here and just say, well, we have the source dot, we want to play whatever is already on it. So we can just say source dot play. The play method just plays whatever sound is already inside the source, whatever the audio clip is, with the settings that are already included in the source. Just drag the audio source, place it in, and there you go. Now that it already has an audio source, wrong audio source, oops, we wanted to do the grenade sound. But well, something went wrong. We don't hear an explosion at all. There's no error either. It's getting destroyed. It wasn't getting destroyed earlier when there was an error, but for some reason it's also not playing an audio clip. So what's going on? Well, let's look at the script again. Here we can see that at the end of this entire script, we destroy the game object, which is kind of what you want to do with a grenade, right? You want to destroy it when it hits. But the audio source is also part of the game object. As a result, well, the audio source also gets deleted. So the question becomes, how do you avoid this? Well, the simple answer is the entire issue is happening because the audio source was on the same game object that you just destroyed. So just have the audio source on a different game object. So how do you do that? Well, let's step back and do something simpler first. We set up all of those audio sources by hand, but as soon as the game becomes even a little bit bigger, that's going to be a pain. You can't always do that, and especially since making any change to it via code is really hard. So instead, the first thing we'll do is make a class called sound. And in that sound class, we'll make sure that we have all of the information we need to edit. And in that sound class, we'll make sure that we have all of the information we need for the audio clip and how we want to play it. Now, I don't want to go too deep into the code, so I'll just show you the code that's already written. It's quite simple, but I want everybody to understand the logic behind why we have different kinds of systems for this, instead of just typing out the code. So anyway, let's keep going. So here we have our sound class. The first thing we see is that it's not a mono behavior. It's not supposed to be on a game object. Inside the sound class, the major things you see here are a name to tell you what the class is, or what the instance of this class would be, an audio clip, which is, well, obviously the audio clip we'd like to play, the audio source from which we are playing the clip, and then all of the various information that you'd need for it. For instance, things like volume, pitch, or loop. You could set tons of other things, and the size of this will vary really depending on your needs. But, well, that's okay. You can make your own one with all of the other features that you like. The next most important thing is the system.serializable on the top. This allows us to have this be public and make sure that we can change it in the editor if you make an array of the sound class, which will come in handy later, as we'll see. So now that we have the sound class, what do you do with it? Well, obviously we want to use this to store all of our information, right? And you want to store all of that information in one place. After all, we're going to be putting all of these audio sources on a single game object, something separate that can play those source sounds whenever needed and never worry about being destroyed or anything else. So for that, what we can do is make a separate script called in sound array. What the sound array will do is, well, simple. It'll just create an array of sounds, and then an array of sounds which we can fill up, right? And next, what it'll do is, for every sound in this array, it will create a separate audio source added to the game object to which we add this script, and then set the settings of that audio source according to the sound instance. For instance, if I say that a single clip, maybe I want to use a gunfire clip with volume 1 and pitch 3, then that's exactly what it will do. It will create an audio source, and for that audio source, it will set the volume to 1, the pitch to 3, and the clip to the audio clip that we want to play. And next, we can just have a function which is called play sound. Now here, we use the sound.names just to differentiate all of the different sounds. So if this sound has the same name, essentially means that it's the same sound instance. Then we'll just play the audio source that's related to that sound using the s.audiosource.play. And we can see that in action over here. We have a sound handler script, and, well, this is an array of sounds. So you can see that I have a grenade launch and a grenade explode already set in here, with volumes and pitches already set. I can add more should I want to. For instance, I could also add another one called gunfire if I wanted to. And if I start, then we can see that over here these new audio sources were created and added to the sound handler game object. So the next thing we want to do is to make sure that whatever projectile we're using, well, it uses these, right? So we can go over to our projectile script, and in here we can add a public sound array called sound handler. Now obviously we need to access the sound handler, right? So to do that, in the start we can just say sound handler is equal to find object of type sound array. This just finds the first object of sound array and set sound handler equal to it. Next we can just go down and add this line sound handler dot play sound dot name dot grenade explode. That just means that the sound handler will play this sound when the collision happens. And over here you can see it works as it's supposed to do. The sound plays even though the game object is destroyed. Though there are still a few issues with it. After all, as you can see, the audio source is on the sound handler game object, which is stationary, which means that this sound will never come from 3D. If I try to set this to 3D, what will happen is that the sound will always come from this fixed location, no matter where the grenade hits. To fix that, well, there's a couple of ways. The first thing you could do is to use something that's already given in the audio source class. The audio source class has a function called playClipAtPoint. What that does is it takes in an audio clip as well as a location, and then it automatically creates an audio source at the location, plays the clip, and then this destroys the audio source. So if you use this playClip3D instead in the projectile and give it the location. Now for the location, I used whatever the collision is, .getContact to see where it collided, .point. The point gives you the vector 3 location of where the collision happened. So now, wherever this collision happens, the sound handler will make its audio source over there, play the sound, and then destroy the audio source. As we can see, the volume is now much quieter if the grenade is thrown. Well, the volume is much quieter if the grenade is thrown far away, while if it's somewhere nearby, it's kind of deafening. So well, that works, except we do lose a lot of control over it. After all, this function that we just used, the playClip3D, and the function that it uses, the playClipAtPoint, well, they only take in the audio clip and the location. If you want to change any of the other features, well, we just can't, right? Say I wanted to change the pitch or maybe the loop, I can't change it. To make our way around it, we can instead do the same thing that this function does, but on ourselves. So we can make a new game object, send it to whatever location that's needed, and then add an audio source on it ourselves. This works just as well as the previous case, and in this case, we can choose any kind of settings we want for the audio source. The one thing that doesn't happen here is the audio source deleting itself automatically. That can definitely become a problem as you get larger and larger systems, but even that can be added in here. But here's the thing, all of this, the code is really quite simple. It's the same thing over and over again. Instead, what I want everybody to focus on is why we used all of these different methods, right? All of these different sound handlers. The first one with all of the sound sources, the audio sources on the same object, that's really helpful for stationary sounds. Things like background music, or things like, well, maybe walking, or something that you know will always happen next to the player himself. Maybe inventory sounds or UI sounds. For all of those, that kind of a sound handler is very useful. But yes, for things that happen in 3D, maybe like the grenade shots or even a gunshot, those things can be done much easier by instantiating a game object at the location. Even then, playClipAtPoint is really useful if you don't really need to control much of anything, and it's cheaper on the laptop too, or whatever PC you use. It takes less processing power. And finally, it's not always good to have equal numbers of audio sources and audio clips. For instance, you may have background music and you only want one to play at any given time. So it's easier to change what that particular audio source is playing than trying to turn on and off different audio sources. Those can be called audio tracks as well, right? And that can be extended to a lot of different reasonings as well. So at the end of the day, even though the code was kind of overwhelming, relax, read it once more. It's not hard at all, it's quite simple. The important part is getting the intuition down, what you need from the sound. If you want the sound to not really care about where in 3D space it is, you can use the sound handler as just a place to store all of those audio sources, especially for things like maybe songs, background songs, which you only want one of ever. You can even use just a single audio source and just change what audio clip it's playing at the moment. But for things in 3D, you definitely want an audio source to be generated wherever the sound is supposed to be coming from. For those, you have different choices depending on how much control you need over the entire system. But remember, there's a lot more to audio. You can do a lot of things and a lot of rules can be broken. So at the end of the day, have fun with it. Enjoy. It's part of what makes games fun. And, experiment. Tell me everything you think I missed. Tell me what other uses you can think of these systems. All of that in the comments. For now, that's all you need to know about sound systems. But keep learning.